Hello, and welcome to this DC Velocity webcast. I'm David Maloney, Group Editorial Director. Thanks for joining us. Today's webcast is the Primus Smart Pick Path, optimizing grocery and retail case picking. Automation is rapidly transforming case picking operations in grocery distribution and cold storage facilities. While some companies pursue full-scale lights-out automation, that approach isn't always the most strategic or cost-effective. In this webinar, we introduce a smarter approach, deploying automation where it delivers the greatest financial and operational impact. Our webcast today is presented by Primus. But before we begin our presentation, here are some tips to help you connect and participate in the webcast. Our webcast is designed to be interactive between you and our presenters, so later in the program, we'll have a question and answer session to allow you to ask our presenters questions relevant to the topics that we discussed today. Just type your question into the text box on the console, then click the Submit Question button, and you can submit them at any time during the webcast. You don't have to wait to the very end when we do have the question and answer period, and we'll get to as many of those questions as we can during our presentation. The slides will advance automatically throughout the event. If slides are not advancing, please press the F5 key or Control R on your keyboard to refresh your console. We also recommend you disable your pop-up blockers. If you're experiencing any technical problems, please visit our webcast help guide by clicking on the help link that's below the media player. Now to begin our presentation, I'm pleased to introduce our presenters. Randy Jennings is Executive Vice President at Primus Solutions Group. Tom Coyne is the President, also with Primus Solutions Group. And our other presenter is Material Handling Expert, Brad Moore. Welcome, gentlemen. It's good to have you with us today. And I will now turn the floor over to Tom to begin our presentation. Tom?
Thank you, David. As David stated, we're presenting what we think is a new and good approach for case pick in the grocery industry. I work with a group of experts at Primus in case picking automation and case picking solutions. And Randy and I started a conversation a couple years ago about how to come up with a better solution. Better meaning providing a better return on your capital deployed. Full automation can be a good solution in a lot of different circumstances. We were searching for the optimal return on your capital. And that's what drove us to this solution that we're here to present today. Let's level set for a second and talk about the history of the grocery industry. In the early part of the 20th century, there are two main drivers that drove the development of a DC-based food supply chain: mass production of consumer packaged goods and farming consolidation. So that really changed the industry. As our economy kept growing, you started seeing more volume going through, larger store footprints, and you started seeing a lot of adoption, full-on adoption of barcoding for automatic data capture, which then led to the approach of using software to run these warehouses. During that time frame, there were a number of approaches and attempts at automating warehouses. I would say it was a case-by-case basis. A company or an operation that had a specific challenge and decided to automate because they might have a land use problem or a labor issue, but it was case-by-case. In the last 20 years or so, that's changed. It seems like the industry has some mega trends driving the requirement to more systemically adopt automation. Our population is growing, but our demographics are changing, and it's harder to find people who work in warehouses, especially the temperature-controlled zones, the frozen and the ambient, the frozen and the refrigerated. So there's been this trend. A number of suppliers are offering fully automated lights-out solutions, and they're being adopted fairly consistently with the larger grocery operations. That said, they can be very challenging to implement. When you think about that, the choices right now seem to be stay conventional, and a conventional approach will keep your capital investment low. You can build a very flexible building that's got high SKU availability, but you don't do much to control your labor costs. Your labor costs remain high, and that ends up being a pretty big building. the alternative with these lights out solutions or automated case pick, and we're going to be using those terms interchangeably. To us, they mean the same thing. You can build a building that's very highly automated. You'll receive your inventory, put it away. The automation handles that. You'll create mixed SKU pallets for your store aisle replenishment. And in the middle, there's really no human touching. These are very high capital investments, very complex operations, very flexible. They'll serve your needs, high SKU availability, and you'll drive your long-term costs for labor, for equipment usage. You drive them to basically the lowest possible level you can. And these buildings, they're generally using ASRS technologies, which means they're using vertical space more optimally. So the square footage is reduced and the buildings are smaller. So there's some good reasons why to think about automatic case picking, but it's a very big investment. As Randy and I had our discussion about coming up with a better solution, we're thinking about this chart. This is a chart that I think describes the impacts of automation on your business operations, and not just for material handling automation. I think it can be applied a lot of different places. If you do nothing and stay with the status quo, on the left, you see the axis that contains cost. Your costs remain quite high. As you automate, and that's the y-axis, you start saving money on your capital cost, but eventually you can over-automate. And what we mean by that is the combination of your capital costs as they amortize over time and your operating costs together means your return, your financial return is getting less. The numbers we have on this chart are from a real case study where we looked at an operation for a grocer, a client of ours. An automatic case pick solution was going to provide a benefit, but it was only a 9% return on their investment. The Smart Pick Path that we'll present to you today was a 32% return on the investment. And this is really what we wanted to talk about, this type of smart, optimal automation where we can deliver most of the benefits without the challenges. So we're just about to present the solution and the elements of the solution, but I wanted to show you the punchline first. These are the results of the study. This was a building that was meant to ship 50,000 cases a day. That doesn't seem high for a grocery operation. I want to tell you that this was just for the freezer part of their business. This was a customer of ours that needed to expand, and the strategy was to build a new freezer and then remission their existing freezer to other uses within the business. So this is just freezer only. The building size you can see there. A conventional building was the largest. The Smart Pick Path actually is the smallest building. You can see what drives the changes in your operational costs. We have in a conventional building, I think it's pretty traditional to say you can pick at 100 to 125 cases per hour. The Smart Pick Path drives that number up considerably to over 300 cases per hour. A lights out facility totally eliminates that labor. So we show some of the other metrics here. We can talk about this in more detail, but what we wanted to show was the impact on operational costs, but also how much money you need to spend on the capital side to get those benefits. And that's where we're looking for the optimal position. Spend the money to get the best bang for the buck and don't go down the curve of diminishing returns. And we think we've achieved that. A 32% return on investment we think is very optimized for these types of investments. So with that said, I'm going to turn the presentation over to my colleague Randy to start talking about the options that you have for automation and for running these buildings.
Thank you, Tom. Let's now take a look at the two examples of the grocery distribution operations Tom's been talking about, both the conventional and automated case pick overviews before we dig deeper into the Smart Pick Path details that we have prepared for sharing with you today. I find it interesting, the details that you see here shared before you about grocery history. If we go back to the grocery history overview, going back to 1920, what is shown here in this information, as seen in some of the existing conventional grocery warehouses for food distribution, could also be the same as what was shown back in 1920 as well. Shown here is what is very typical of storage methods incorporated into conventional warehouse food distribution facilities. Not only do these types of rack storage systems serve both for holding the inventory, most often the order picking for order fulfillment is the bottom level of these storage areas, requiring the use of large spaces for completing case order picking. For the marketplace that we are sharing this comparison, orders are most typically well above 95% pure case pick and seldom, if ever, shipped out as full pallets of single SKUs. We'll see here soon in this meeting there are many types of equipment technologies readily available now for operations to help minimize the long-term care cost of labor for order picking. So what we see here are two very important areas of operation inside this conventional operation of a food distribution: case picking for order filling and shipping, and then also the loading dock itself for shipping the product out. When you go inside conventional facilities, there are aids being used for order filling, like shown here. Case picking using headsets with order picking details shared electronically. Once a pallet is picked, then delivered to the dock, where pallets get consolidated onto outbound trailers and shipped to stores. Some of these practices continue today in more automated facilities where the best value for filling an order is by an order picker, but most pallet movements become automated in those facilities. Here, as we're seeing in conventional facilities, everything is still done with people doing the manual material handling and movement utilizing forklift equipment. So I know that that's a very quick overview of conventional handling, but in the interest of time, we're going to move forward then immediately into the opposite end of the spectrum, and that would be the lights out ACP. As you saw earlier in the grocery history overview, Tom shared automated case pick. It's been around since the early 2000s to today. Many people incorporate it. Primus has built many of these facilities that are totally at the opposite end of the conventional facilities. These ACP facilities utilize many forms of technological equipment to assist in order fulfillment. One prime example is ASRS, or automated storage retrieval systems, which many people have seen in action, but you may not have seen these systems working in close concert within facilities where, when we stop and look here at the picture, for example, in the top left-hand corner, pallets of products as they arrive to the distribution center get unloaded from trailers by forklift operators and then get inducted directly onto inbound conveyors for quality control checks and validation before automatic entry into the ASRS. There's no additional handling or movement via forklift or pallet jacks. The handling is all done through automated conveyance. And then it goes over to the picture on the top right-hand side. Once pallets are received, the ASRS system puts them away for bulk storage. Again, as I said, we're talking about operations where it's 95% case pick, so we're not going to be sending that full pallet back out. So the pallet ASRS releases pallets on an as-needed basis to travel out from the ASRS to get cases removed and ready for order filling. Then what we see in the bottom left-hand corner is a Cubica head layer picking robot. It's used in many food distribution operations. People use it all around the globe. Pallets arrive to the robot stations to get cases removed as a layer for storage at case level to be used for order filling. Typically, the pallet, when it comes into the station, will get cleared of all cases, and the empty pallet leaves the station. On occasion, with really slow-moving products or the slow-moving SKUs at the far end of the Pareto curve, only a few layers of cases may get removed, and the residual pallet will be returned to the pallet ASRS for consumption later. The next very important step in this process is in the bottom right-hand corner. The bottom right-hand corner is, once the cases have been removed by the robot layer picking system, they get singulated and conveyed to be stored. These cases are stored for filling as shown here in an ASRS as well, but it's at a case level and not pallet level. The system has been designed specifically to hold the product that's of that size. The example shown here in the picture on the bottom right side is a case handling shuttle system for high speed throughput capability for getting cases out in the right sequence for order building. So there's a lot of different elements. You heard Tom say earlier, a lot of these systems that make use of automated storage retrieval or automated storage retrieval systems. Here in just this slide, we're showing that there's two different types that are being incorporated. Once we get past that and we've had the product received, put away, handled in bulk, and then stored at the level where it's ready now for what's being done to move the product into a position to fill orders, it becomes very important. So let's take a look at this illustration shown on the screen that shows an example of a complete ACP operation, a facility that starts and ends with the truck docks. The product coming in as bulk, orders being fulfilled, product being prepared and ready to go back out and be shipped. So what you see on the right-hand side of the picture here is the building. It's showing the pallet ASRS, which in this site you can see it's not too large. Typically, people associate a pallet ASRS with large capacity storage, but not in this facility. Here, the system is intended to hold pallets for a short period of time and turn the inventory over very quickly. So you don't see this as being one of those large pallet ASRS systems that's done just to inventory product. They want to get the product in and consume it in a timely manner. In the bottom left and bottom right of this screen, where you see red stacks, that's where the Cubica layer picking robot stations are located for cases to get removed by the layer from the pallet and sent off to the case shuttle system for in-process storage. That's what you see in the middle top. That shows the case storage in a case shuttle with high-speed throughput capability for getting cases out in the proper sequence for order building on the store-friendly pallet. As you can now appreciate, the product that's being stored inside that area has all been individualized to individual SKUs, making itself available. When orders are being picked for a store, they want to make the store-friendly pallet so as it goes down the aisle, it's easier to put the product available for the consumer to get access to. You have to have a wide variety of those SKUs available as individual units. So the last piece then, as the cases come out of that case shuttle system as an ASRS, they get delivered for building the store-friendly order pallet. That's actually shown better on the next slide, so I'll index forward to it. And what we see here, this is one of those facilities that I told you that Primus has proudly built that incorporates automated case pick. And what we're seeing here now is the final processes in building the store-friendly pallet for delivery to the local grocery store. On the lower right side of the picture, shown here are the pick-and-place robots that are receiving the cases as sent from the case shuttle ASRS. Each station receives the cases and automatically builds each pallet on top of the black plastic store pallets as shown on the left side of the working area. Those pallets go out to the stores and they get returned back for use for distribution in their own network. The store-friendly pallets are being built up inside the blue and gray housings that you can see that are in the work-in-process area for pallet building. Once each order pallet gets built, it's then sent to one of the 3 automatic stretch wrappers. That's the stations that you see are the red and blue towers shown here in the top right of the picture. Each pallet, once wrapped and ready for distribution, then gets conveyed to the outbound loading dock for loading onto trailers. So I'm not showing you trailers now, but I am showing you an element that's very, very important to the operation of an automated case pick or lights out facility. As you can imagine, with making the statement automated case pick and lights out, for an automated case pick facility to work properly with the steps that it takes and shown in the 3 previous slides, these facilities require a complex software system for order management and warehouse inventory control. These systems are implemented, require good management and support staff to ensure long-term operational success and efficient operations. So the Primus Smart Pick Path. As I said, Primus in the past 25 years has enjoyed many opportunities across the country to be the preferred design build firm for many facilities that we have been reviewing the different operations. In these last few minutes, we've seen some ways that companies still employ today for conventional operations, very similar in content to what was done past 100 years ago. We also took a look at the totally opposite end of the spectrum of ACP distribution centers. Earlier, we shared some high-level comparison summary of these two means of operation as compared to Smart Pick Path, the conventional distribution center, and the ACP distribution center. So now it's time to take a closer look at what is being done with what's being shared today, the Smart Pick Path. Smart Pick Path is taking the best of both worlds as shown here with better value for your operations. Tom, I look forward to you sharing those more details with the audience.
Thanks, Randy. This slide, we have some bullet points. The key issue here is we're using ASRS technologies in a creative but pretty standard way to do most of the picking. And the picking happens in pick tunnels. And we have an optional goods-to-person picking module for slow-moving items. Here's the real punchline of the whole reason why we think the solution has so much value. In a traditional pick tunnel environment, you run out of space for SKUs, so you can do your order fulfillment. And this solution is specifically specifically engineered to handle a much higher SKU range than typical, and we think that makes it suited for the grocery and food service industries. There's a corollary benefit too. You've got a pick path. You've got many more SKUs in that pick path, and so you're going to get a lot more picking productivity. And because the automation is there to support, still people doing the picking, there's less automation. So the reduced capital cost does create a much higher rate of return for your operation. So what is this? I'll show you the first few elements first, and then we'll look at a bigger schematic of the solution. The picture on the left, ASRS with pick tunnels, that's kind of the beating heart of the system. What makes it better than a traditional ASRS with pick tunnels is the second picture we call layer tray loading. Within these pick tunnels, we're creating a new type of pick face. Not everything has to be pallet size. In real systems, there have been some solutions delivered where you have pallet size pick faces and less than pallet pick faces. What we're doing is maximizing that by having for your slow movers on your Pareto curve only a layer tray available, because that's really all that's needed to sustain picking based on the movement of those particular SKUs. This has actually been done in a couple of different cases in the grocery industry. Where we've taken it further is the addition of a case buffer. On the schematic on the bottom, you see where the arrow points to the case buffer. You also see where an arrow points to what we're calling low velocity SKUs pallet buffer. That is the inventory to support the case buffer operation. So those two combined, we believe, adds up to 2,000 more SKUs to this picking approach. And that's really what we've been focusing on, is how to bring all your products together so they're available without having to have these high-speed single case buffers. So you can run your business, you have availability of all your SKUs, but you can do it with less spend on the automation. One last point I want to make is on the bottom right. We've got a custom engineered tray. It's called a split tray. And in the pick face, these pick faces become pretty dense. What that allows you to do is not have to reach deeply into a pick face to get a case in a confined space. And we'll show that how that works in just a minute. So these are the different elements. And now let's start going through this piece by piece. ASRS with pick tunnels is a solution that's been deployed in industry for decades. But some of you might not have seen it. So I'm going to show you a quick video so you get a sense for how this type of operation would work. So you can see there's a crane that's coming to deliver a source pallet to the picking location. You can see the person doing the operation. The pick location is too deep, so there's reserve back there. So he let that pallet come forward so he continues picking. That type of picking can be very productive. Replenishment activities are minimized because the cranes are handling it automatically, and you've got a nice clean pick path for the operator. Let's talk about layer trays and what that does to the system. What we will do is use what Randy described earlier, a layer picking robot, to take cases off a source pallet or an inventory pallet and load them onto a layer tray. That layer tray will then be conveyed to the cranes, and the cranes will then put them away into a pick face that's meant for a layer tray. Some more details on layer tray loading. Just showing you some of the details on the the conveyor design and how the cell will work, but it will basically be an arm robot that will be grabbing trays and placing them onto the layer trays. This is probably the most important slide in our presentation, and it doesn't look important, but it gets to the point. The picture on the bottom shows a conventional pick tunnel, and if you look at the second level, and you look to both sides of the pick tunnel, you can see those are pallet-sized pick faces. That's typically what's been implemented in many different companies over the years. And the fact that the pick faces are not designed against the movement of each SKU means that you end up doing a lot of walking. Even slow movers end up with a pallet-sized pick face. The picture on the top left, where you see the red bubble, this is really the key point to this. We are, through the layer tray loading cell, we will be looking at the velocity of the SKU movements, selecting the items that don't move as fast, and creating layer trays for picking, and then loading them into the system. When you look at this volumetrically, you can really use a lot of layer trays. And it looks like we're only putting layer trays on half. On the other side, it's probably a combination of pallet size and layer tray sizes. So what does that mean? You can triple the amount of SKUs that are available for picking as the operator goes down this pick path. When you're picking, density matters. If you can get more SKUs for every step the person's taking, that person's going to be a lot more productive. So now we're moving into the next evolution of this solution, the addition of a single case buffer. That single case buffer has been designed to add another couple thousand SKUs to the system design. It starts with having the inventory available. We're going to show a video of another ASRS technology. There it is. This is how we'll bring product available for the case replenishment. This happens to be showing a shuttle-based ASRS instead of a crane-based. The design of that is based on the circumstances of each individual project. But in this case, we looked at it and said it's probably best to use these types of pallet shuttles. And that's the low-velocity pallet SKU buffer. As we move forward, now you've got a case buffer. I think the video is still playing. So if you just bear with me for 1 second, I'm trying to advance to the next slide. David, can you confirm that you're seeing the slide, the next slide of the presentation?
Yes, I think you should be good at this point.
Okay, great. So I'm going to show another video here, a short clip of technology that can be used for the case buffer. Now, I think a lot of people on this call may recognize that as a technology called AutoStore. AutoStore is one of a number of different types of case buffer technology. We're showing it here because it was an interesting clip. In the design, there's options for what kind of case buffer technology to use to execute the intent of the system. The case buffer is meant to be a loose case top-off operation. We're trying to minimize the amount of touches, and what we don't want to do is pick in parallel and then have to consolidate on the dock. So the way the process would work is the majority of the order picking happens in the pick tunnels, and then the last stop on the pick path would be at the case buffer to gather the last 2 or 3 cases for that pallet for that order. So there's a schematic of what the pallet buffer would look like. There's surprisingly a fair amount of pallet movements. The way we'd operate the system is we'd be bringing pallets out to a goods demand picking station, and they would be picking the cases that are needed for the next day's pick. So there's enough pallet movements that we went with a pallet shuttle approach. In the case pick buffer, the current design shows a small mini load style piece of equipment between 1,000 and 2,000 SKUs on hand, only a few cases per SKU in the buffer. The cases come from the manual pallet buffer and are decanted manually. Pick pallets are just topped off at the buffer. There's not a lot of activity happening at the buffer, but it allows you to complete the order in an efficient way. So in summary, we've got an ASRS with pick tunnels, but a creative approach to the slotting of those pick tunnels to drive productivity. We've got the layer tray loading automation to support those different types of pick faces. We've got the pallet buffer that supports the case buffer for the final manual top off. There's not a lot of activity for the case buffer, but it allows you to have a wider range of items available for your order fulfillment, which we all know is what's happening in industry. SKU proliferation is driving so much of how we're running our distribution centers that we wanted to maximize the amount of SKUs that could be handled within this system. I'm going to hand over the rest of this to Brad Moore. We asked Brad to evaluate the work that we've done at Primus. And Brad, why don't you take it from there?
Good afternoon, and thank you, Tom. I saw on the introduction page that someone had listed me as a material handling expert. I think more of a material handling survivor is a better title, staying up and ahead of evolutionary technologies of the smart pick path and away from the revolutionary technologies like full automation and like one of my favorites over time, levitating rackless storage. Not there yet, someday maybe. I'm excited for the opportunity to review the Primus Smart Pick Path solution, share my experiences and that of my clients over time with you, Randy, Dave, and the DC Velocity audience. From my review of the Smart Pick Path solution, I find it a new approach to a common opportunity, a new solution using proven technologies and the simplicity and familiarity of existing SOPs and processes. So it's definitely evolutionary and not revolutionary. So I'll go back to maybe a small example. An old adage, time is money. In warehousing, time and space is money for sure. As an example, let's say a typical grocery warehouse has a 10-20 or 10-30-60 ABC split, fast, medium, slow mover split. When you start looking at that particular split, if you have 2,000 SKUs and you do it in the conventional way where you have one pick slot per SKU, 2,000 SKUs times about 5 feet per SKU is a 10,000 foot pick path. That's a long path that you have to accommodate with racking and your pickers are constantly walking past products. In the Smart Pick Pack solution, you have fast movers, which are on full pallets, maybe even a couple bays of those full pallets, depending on how fast they are. Half pallets for the medium movers, and then you look at trays and split trays for the slower movers. So you may end up with 200 rack slots of fast movers, 600 medium SKU faces, but that equating to only 300 half pallet rack slots and 1,200 slow moving SKUs, which could be as little as 300 rack slots. So now you're looking, instead of a 10,000 foot pick path, you're looking at a 4,000 foot pick path. That's a 60% improvement in the length of the path, and which equates and translates to labor reductions and associated associates and workers walking past products with every order. So the very best of both worlds, storing pallets in the full pallet quantities or the largest pallet quantity possible, that's most cost effective and most efficient storage medium, and then breaking it down as needed for replenishment automatically to smaller SKU faces to fully achieve the savings and efficiencies of the pick path. Huge picking efficiencies there. I'm going to slide to the next slide. So another opportunity that we're dealing with the conventional versus smart pick versus full automation is time. And time is money as well, as we said. And sometimes you can see that the lead times here, where you put in a conventional building, 9 to 12 months, including permitting sometimes, is a lead time for a conventional, and for full automation, up to 21 to 24 months. And with that, you're also looking at ramp up times that for full automations, full changes of processes, new software, different opportunities. With a full automation solution, you can run into an opportunity where you have 6 to 9 months of ramp up time and high automation. The smart pick path takes the best of the existing world and accommodates and provides the efficiencies of those operations that are still consistent and good. So change management style, the conventional has a very low change requirement. Full automation is a high change requirement, and the smart pick path, you're not throwing out the baby with the bathwater. So a couple other things, and really quickly get through this. Store aisle friendliness is another opportunity, especially for brick and mortar opportunities. The smart pick path allows the warehouse to be organized effectively by fast movers, slow movers, and medium movers, and to make the pick path more efficient for each aisle or category in the store, or even for picking for store pickup orders of that magnitude. Another thing I like about the it's easy for you to say, the smart pick path, is that the solution itself has a lot of flexibility. If the stores change and or your business plan changes, you can migrate more product to the pallet storage and less product to the case storage, or vice versa, to make that happen. And I think one last thing there for this is site selection. In addition to the lead times, site selection also becomes very advantageous for smart pick path and for full automation, because less land allowing for you need less land. So it can allow for a higher per acre price tag, so you might get a more opportune site. A smaller site allows for a selection closer to where you may have warehouse labor or skill sets. And it also may be somewhere where you can actually put a building closer to your customers, maybe in the city. So those are just some basic considerations that I think were very important when I took a review of the smart pick path. So Tom, I truly appreciate the time. I hope I didn't take up too much time, but I appreciate the missionary solution, smart pick path. And now I'm going to turn it back over to you for a quick wrap up or any questions.
Thanks, Brad. So we've hit most of these points, but I just want to go over them again just to make sure we fully communicate. This is kind of a solution where you're going to gain most of the benefits of a fully automated solution, but at a much lower investment cost. There's a lot of technical risks going to automatic case picking, and it requires businesses to really staff up to meet those risks and run the systems well. The solution we're presenting, yes, it does have automation for sure. There are ASRS cranes, there's a robotic cell, there's conveyors. For pallet transportation, we're using a monorail system. So yeah, there's equipment in this system for sure. I don't want to minimize that, but it doesn't expose your business to the same level of technical issues that an automatic case pick system does. It's just it's an automated system, but using pretty standard technologies. Brad mentioned ramp up. Meeting your business goals as soon as possible after a system's installed is a critical component to getting the financial return that you promise to your bosses, to boards of directors, to executive staffs. And the ramp up of automatic case picking in the industry seems to be pretty long. This solution we're presenting will ramp up very quickly once it's commissioned and integrated. Brad's already mentioned the reduced land usage. One thing besides site selection, a lot of our customers, we start working with them on a multi-phased approach to work with their business over a defined period of time, in phases, so they can scale up and meet their future growth. Doing this type of solution, you're going to use the least land possible as you deal with those issues of growth over the years. So if you have a site that you're looking at, and you can get twice the throughput, per square foot, that's going to allow your business to expand the most. And then finally, this issue of capital. There's a lot of different constituencies within a business, fighting for money and fighting for capital spend. It's really the hardest budget to fund in almost any business. So saving capital for other uses and other needs in a business just allows more critical needs to be served through that capital budgeting process. So that's why we think there's a lot of value here. What we presented was a innovative approach of combining existing technologies. There was not really anything in this solution that's new product development. It was really the combination of approaches and thinking through the data and thinking through the operational flows within a warehouse, so we could come up with something that's clever, something that's just a way of reducing cost by designing better as opposed to inventing better. So I hope this subject matter has been interesting to everybody. And I think this is the time where we'll open it up to questions from the audience.
Thank you, Tom. Yes, it is time, as he mentioned, to move into our question and answer portion of our presentation. And if you did not yet send in your question, now's the time to do it. Just type it into the console and submit it to us. We'll get to as many of those questions as we can in the time remaining. First question: what SKU range or item profiles are best suited for pick tunnel processing versus the pallet or case buffer zones?
Yeah, so the pick tunnels will generally have your faster mover items, and the fastest moving items will remain on pallets. The medium moving items, we will convert those into either half pallets or layer trays. And then we have the option of the case buffer for your slower moving items. You don't need the case buffer if you don't have that large a SKU range. And those slower movers can be served off of layer trays. But as we've talked about in this presentation, SKU proliferation is a real issue, especially in the food distribution environment. Food manufacturers keep making up new types of frozen goods, new type of packaged goods, different sizes, different amounts. There's now, all sorts of alternatives for health or for allergies. So SKU proliferation is a big deal. So we'll look at that Pareto, and the slower moving items will be in the case buffer, the medium movers will be in the trays, and the faster movers will be in the pallets. I hope that answered the question.
I think so. Anyone else to add anything to that?
No, I think he's spot on.
Let's move on to our next question. Obviously, trying to install this kind of system, if you're operating a facility right now, is a challenge. So what's a typical ramp-up timeline for the Smart Pick Path in a retrofit versus a greenfield environment?
I'll go ahead, Randy. I think there's a couple things to mention here. We show this as an ASRS-based system, and that might bring up the idea that it's going to be a very, very tall building. The solution that we presented was less than 60 feet tall. Okay, so this doesn't need to be very tall, and it can be done in a retrofit. Okay, because we want to have the reserve storage area in the ASRS. But, generally speaking, it doesn't need to be tall because we need the cranes, the ASRS pallet handling equipment is replacing other types of automation. So we need a few extra cranes to handle all the movements, which means we don't need to go very tall. So now that's the introduction to the question. If you were doing this within an existing building as a brownfield project, we would get the installation done, we would get the system integrated, and I would say you could start retrieving product almost immediately afterwards. And in terms of, hitting, your goals for throughput and getting your inventory transitioned, a few months is what it would take. It wouldn't be much longer than that.
Okay, very good. Thank you. We saw the chart making the comparison between this type of a system and traditional lights out, but what types of labor skill sets are needed to operate and maintain this system versus that traditional or lights out approach?
Okay, I'll answer one more, then I'll force Randy or Brad to answer the next one. What you saw in that chart, you saw us get down to, with the Smart Pick Path, a 60-person operation. And then you saw on the fully automated system down to 50 people. There's actually a bigger savings in picking labor. But running the fully automated building, you do need a more staffing for the maintenance, for the IT support and the operational support. We still need some of that labor talent to run the building that we're suggesting. There is ASRS systems, there's conveyors, there's robot cells, and there is software making it all run together. So there's going to need to be some people that do some planning of how you run the orders through the system. And you're going to need a competent maintenance staff to take care of the equipment in the system. So you do need some labor skills, and it's more than you would in a conventional building. It's probably about halfway in between running a conventional building and running a fully automated building in terms of the number of people that are technically trained and the level of their training. But
Tom,
yes,
I think if I can jump in, Tom, real quick, I think one of the things when I was doing this around the turn of the century for a little retailer in Northwest Arkansas, I had an opportunity to share with the maintenance manager. He was asking me what it is. It's really a mindset change for change management. And that is, with Smart Pick or with full automation, the maintenance team is no longer stick a fork truck in the corner and we'll get it tomorrow. It's got to be Johnny on the spot. So they have to understand that maintenance is a part of the operation, not an adjunct to provide equipment support for the operation, which can happen at any time. So it's an important one, as you said, somewhere between those two, but it's that mindset change that has to be there, that they've got to be ready to solve the problem now rather than waiting a day or two.
Yeah, Brad, and not only do you see that when they talk about their maintenance staff, you can also see it when you go to these facilities that do have automation in place. The operational people take it upon themselves to find shortcuts to improve upon the operation so that should something come up as a hindrance to their operation, they themselves know how to address it and keep the system running quickly and efficiently. Because they see that what they've done is management has made an investment into them, into their future, by investing into technology. And they do everything that they can to make the best use of that technology and not take a hands-off approach. Rather, they take a hands-on approach of being able to service and support all the equipment.
Makes sense, gentlemen. We have time for just a couple more questions. Again, if you haven't got your question into us, go ahead and send it to us right now, as we are just about to wrap up with just the final couple of questions. This one is coming in from a viewer wanting to know why cranes versus shuttles. Does it have something to do with redundancy and risk?
I'll answer it, Tom. What we were looking at so far when we did this Smart Pick Path comparison, Primus in the solutions group, we've developed what's called the ROM tool that affords us the opportunity to be able to take a look at where the best capital investment is for the type of solution that you're looking at. For what we looked at for the throughput and the needs of what was required, that gave us the best return on investment for the consumer and minimize what they would have to do for the capital investment overall.
Yeah.
Yeah, Randy, I think the one thing I like to compare with pallet shuttles versus pallet cranes is one is horsepower and one is volume and storage. Your crane system will have less horsepower capacity than your shuttle system, but that, as Randy said, it has to be calculated and understand how many movements you're going to have to replenish these smaller pick faces. And whether shuttles is the right answer or cranes is the right answer is something that is dependent on each and every scenario.
Yep.
Yeah, there's no one size fits all.
Yeah.
Right.
In addition
Correct.
to what Randy and Brad said, there's one technical challenge that we were dealing with, and that is getting a pallet into the pick face safely. The crane that we're using in the solution has shuttle forks, so we can get it into the pallet flow rails and let it flow down safely and keep the operator separated from the crane operation. With the shuttle would have to drive into the area. And there are some companies right now working on that with shuttles to come up with an approach that will do that safely. But it's not as space efficient and not yet available in a safe way. I know it's coming, but right now that was also a key issue. You need to run that operation safe, and you need to replenish those pallet flow rails in a way where the operators, there's no risk. So it was kind of an OSHA issue as well.
That makes sense. Our next question, how have your clients handled change management, particularly when transitioning from a manual or semi-automated operations to the Smart Pick Path? Change management is also always difficult. How have they done that?
I'll answer it first. Not very well. I will say that people don't like change. Change comes very, very hard. And they need to start well in advance of the installation and understand and get their people involved in the change of processes very early, with the explanations as to why they're doing it. Because the number one thing they look at when you start talking about picking and automation and things moving around automatically is, so are they taking my job? Where's my job going to go? What's going on here? Why are we doing all this automation? If you explain it to them up front, give them the opportunity and an understanding of why things are the way they are, it's good. It's easier to do it in a brand new building because you haven't had practices in place. When you talk about that retrofit that was mentioned a few minutes ago, that makes it a lot more difficult because they're ingrained in the processes they have. Some of those processes are going to change. Full automation might be tough. The Smart Pick Path uses a lot of the existing operations, so it makes it a little simpler.
Now, we try, I want to just chime in there. We've been trying to make this presentation about the Smart Pick Path, but I do want to talk about Primus and Primus's business model because it helps there. Because change management is about planning, and planning takes time. And Primus's approach is we call it design, build, automate, where we're working together with our clients on the architecture, the building, and the automation inside the building, which means we start sooner with that planning. And so that allows us to work with the customer in terms of how they need to communicate within their company, the culture changes that are required to adopt automation, this whole process for change management. We like to start earlier so there's enough time so our customers can be better prepared for it. And I think this process of design, build, automate makes that easier. So, yeah.
We have just a few more minutes left. Let me ask one more question. And you talked a little bit about maintenance earlier. So how does the Smart Pick Path model compare in reliability and uptime to fully automated lights out types of solutions?
The uptime, the availability, I'm going to break that down into two things. One is predictability. These fully automated solutions are so complicated that you can have unexpected events cause interruptions to productivity, to throughput. If anything happens and you get out of sequence getting cases to the palletizing robot, that's lost time and that's lost throughput. So there's that issue about sustainability of the throughput during the day. That's a issue that operators work with. In terms of the uptime, I think there's a direct relationship between the amount of equipment, the amount of automation, and uptime. It's the law of averages and law of odds, I guess. And a fully automated solution just has so much more equipment in it. And some of the equipment is very technical. It's very high-speed equipment there's more chances for downtime. So I think it's just kind of almost a linear relationship between the amount of equipment and the complexity of the equipment. So it's not linear, it's variable between those two. The Smart Pick Path, we really tried to stay with tried and true technologies. And the dependencies aren't there between the solutions. If an ASRS aisle is down for any reason, you can have products slotted in multiple areas, and you can continue picking even if one piece of equipment's down. That is harder in an automated case picking environment.
Right. Makes a lot of sense that there's redundancy, and as you said, tried and true equipment. How would someone get in touch with you if they wanted more information about this?
Yeah, so I think what we're recommending to people is to contact us through primusbuilders.com. That's our website, and it's as it's spelled, primusbuilders.com. And there's a page on the website where you can ask for a contact to be made, and I think that's the best way to handle things. Reach out to us through our website, and we're anxious to talk to people about this approach, and we're anxious to come visit and meet with you and see if it fits your business needs, for sure. So primusbuilders.com.
Great. Thank you. Fortunately, that is all the time that we have. Yes, I'm sorry. Please go ahead.
I'm sorry. And I'm available if you want to hit me up on LinkedIn. I check it often, and I will get in contact with you as well.
Great. Thank you. As I said, that is all the time we have for today for our question and answer session and our presentation. If we didn't get to your question or you did not have a chance to send us one, go ahead and submit it anyway, and we'll have someone follow up with you directly. And again, we encourage you to go to primusbuilders.com for more information on what we've discussed today. Shortly after this live event, you'll receive an email reminder to access the presentation on demand. You can view it once again, go over what you might have missed, or share it with a colleague. Thanks again to our presenters, Randy, Tom, and Brad, for a great job today and a very informative session. Thank you, gentlemen. And we'd also like to thank you, our viewers, for being with us. We know your time is valuable, and we appreciate that you chose to spend part of your day with us today for this webinar. For all of us at DC Velocity, I'm David Maloney. Have a great rest of the day.